everyone, for today's lesson we are going to learn how to measure and classify angles. Our learning targets for today is for you to be able to say, I can name, classify, and measure angles. The key word here is classify. That is a new word that we will have, and that is to put something into a category. Next, we also have I can apply the angle addition postulate, which is very similar to the segment addition postulate that we have already learned about. For this lesson, you will need a glue stick, some scissors, something to write with, and I strongly recommend that you have some highlighters and color to help you emphasize certain words. You will also need to make sure that you print out the Unit 1, Days 7 and 8 cutouts for this video lesson. I'm using different paper, and I already have them already pre-cut out. So the first thing that we are going to do is we are going to create the same exact type of cutout that we have throughout each of our lessons. So what I would like you guys to please do is please go ahead and take the vocabulary words and paste them into the center of our box. So you can use glue or you can use Scotch tape. Whatever materials you have at home is perfectly fine. And we are going to glue this box right into the center so that there is space on each side for us to write. Next, I'm going to cut parallel lines going right up into each of the lines of the boxes using my scissors. And what this is going to create is tabs so that we can write down information. Here we go. So the first vocabulary word that we have is the word angle. And that's very fitting for us to talk about since this lesson is about measuring and classifying angles. An angle consists of two different rays. So we're talking about two rays that are going in different directions. They have the same endpoint, where the sides of the angle are rays. And the endpoint of the angle is called a vertex. So an angle looks like this. I'm going to draw an angle where I have two rays, one ray going in one direction and one ray going in the other direction or another direction, and they share a common endpoint. This endpoint is called a vertex. A common vertex. We always label angles with 3 letters, so I'll call this A, B, and C. And sometimes we label angles with a number, so I'll call this angle number 1. A lot of times you will see arc marks inside, maybe 1 or 2 arc marks, and matching up arc marks will tell you whether or not angles are congruent. There are four ways to name this angle. The first way to name the angle, which I believe that I have it right here. There are 4 ways to name this angle. The first way is to name this A, B, C. So we're going to call this angle with an angle symbol, A, B, C. Or you could call this angle C, B, A. You could call this angle B by naming it with the vertex. Or you could call this angle number 1. So there are 4 ways to name this angle. In this angle, we have B is the vertex. And we have ray BA and ray BC. They are the rays that make up the angle. So ray BA and ray BC are the sides of the angle. They are the rays that make up the angle that we are talking about. So it is 2 separate rays coming together to form an angle, with the center or their common endpoint is considered the vertex. Please note that whenever you name an angle, the vertex has to be in the middle. So I'm going to write that down. The middle letter must be the vertex. So whenever you're naming, make sure that the middle letter is the vertex of your angle. The next word that we have is array. And array that divides the angle into two congruent angles, or to two angles that are congruent, is called an angle bisector. So we're using that language of bisector once again. And what that looks like is I'm going to draw an angle. I will label this angle E, F, and G. And we are looking at a ray that divides an angle into two congruent angles. Would be an angle that is, or a ray that's coming out of the center. We'll call this H. And what it does is it forms two congruent angles. So you'll notice that each side will have the same arc mark. So in this case, ray FH is an angle bisector. Because it is a ray that cuts this angle into two congruent pieces. So we have two angles that end up being formed. The first angle is called EFH. So this is angle EFH. And our next angle is HFG. So angle HFG. So these are our two angles that are formed, and they are congruent to each other. And they are congruent to each other because they have the same arc marks, and we are told that FH is an angle bisector. Remember that bisector means to cut in half. Or to divide into two congruent pieces. Congruent angles. In this problem that we have up here, we had two congruent angles. Congruent angles have the same exact measure. And you can tell with arc marks, or you might be able to tell with the actual angle being named. So in this case, we had angle EFH being congruent to angle HFG. Please note that we use congruent symbols whenever we just have an angle symbol. But when it comes to equality, just like when we were talking about segment equality, we will use the language of measure, or a little m. So the measure of angle EFH is equal to the measure of angle HFG. It is not congruent. What this little m represents is it represents an actual measure. Represents the word measure, and a measure is an actual degree. So it'll be like x degrees is equal to x degrees, or like 25 degrees is equal to 25 degrees. All right, let's go ahead and fold these pieces in. The first vocabulary word that we had was angle. Remember that an angle contains a vertex with rays coming off of the vertex. So it contains a vertex with rays coming off of it. The next word was angle bisector. And third, we had congruent angles. Congruent angles are angles that have the exact same measure. What I would like you guys to please do is please paste our cutout on the side because we're going to write down some information on the other side. Here we go. So the next thing that I want to talk to you guys about is this thing called the angle addition postulate. Very similar to the segment addition postulate. The segment addition postulate said that part plus part equals whole. That is the exact same thing that we are going to have here with the angle addition postulate. Remember that the word postulate just means that it's a statement that has already been proven true. So the angle addition postulate follows the exact same rules as what we saw in segment addition postulate. It reads that if P is in, so point P is in the interior of angle RST. Keyword here being on the interior, so that means in between or inside of angle RST. Then the measure of angle RST is equal to the sum, which remember that the word sum means to add. It's what you end up getting after you add. Then the measure of angle RST is equal to the sum of measure of the angle RSP and the measure of angle PST. So this looks like a lot of letters. So what I'm going to do is I'm going to draw a picture representing this situation. So what I'm going to say is point P is in the interior of angle RST. So let's go ahead and write that down. Here is angle RST. Here is point R. S is in the middle, so that means it has to be the vertex. So here is S, and here is point T. We are told that P is a point in between or on the interior of the angle. So because we have point P is in the interior of angle RST, we are going to draw a ray going from S and going through P. What this creates are two different angle measures. They are not necessarily the same because we are not using the language of angle bisector in this problem. So what I'm going to say is that if P is in the interior of angle RST, so here is my whole angle, then the measure of angle RST is equal to the sum of the measure of RSP and the measure of angle PST. And so that's how we end up with part plus part equals whole. So the measure of angle RST, which is the whole angle, is equal to the measure of angle RSP plus the measure of angle PST. And I'm going to use highlighter to talk about it. So the whole angle is equal to one part plus the other part. And this is where part plus part equals whole once again. So this is whole is equal to part plus part. And so sometimes there's going to be different angles that will suddenly add together to equal a whole angle. And that is when we get to use the angle addition postulate. All right, so this is what some of the different types of problems that we are going to be working with and using. But there exists different types of classifications. So the word classify means to give it a category. Classify means to put in a category. And there are 4 different categories of angles. And this language of classify is going to be something that you will see in your homework. So the first type of classification is called acute. So an acute angle, ACUTE, is an angle whose measure is less than 90 degrees. And we would say, if I drew this angle, that x degrees is in between 0 degrees and 90 degrees. So an acute angle is an angle whose measure is between meaning in the middle, or between, just like we see here, is between 0 degrees and 90 degrees. So something like 50 degrees would be considered an acute angle. The next type that we have is called a right angle. RIGHT, a right angle. So this is a picture of a right angle. You will likely see a box inside indicating that it's a right angle. And that angle has only one measure, and it is 90 degrees. So if you see an angle whose measure is 90 degrees, then we call it a right angle. The next one that we have is called obtuse. Obtuse, O-B-T-U-S-E. And that angle looks something like this. We'll call it x degrees as well. And that is an angle whose measure is between 90 degrees, 90 degrees and 180 degrees. So what you would see is an inequality of 90 degrees is less than x degrees, which is less than 180 degrees. The last type of angle that we have is called a straight angle. S-T-R-A-I-G-H-T, a straight angle. And a straight angle is a straight line with 3 points on it. Excuse me. We call it x degrees. Once again, I take it back. It's going to be a straight angle, and it is 180 degrees. So an angle whose measure is 180 degrees, that is called a straight angle. And all lines are called straight angles. This is true for all lines. So any line that you see is considered an angle, and that angle is called a straight angle, and that straight angle is always 180 degrees. That is the end of today's lesson in our notebook. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.